I wouldn't see market fit as something that is at 0 to 1, in the sense it's either you have it or you don't have it. I think it's constantly progressing and constantly changing, and it's something you should constantly be chasing and refining. Because even yeah, I think it's constantly evolving, and at each stage, product market fit will change based on basically how big you want to grow, or what's the strategic direction you want to take. But I think what's important is that to make sure that you're not derailed too far off, continue to have touch points with people that you'll be selling the product to. So throughout development, keep on having those communication channels open. So initially for us, for example, it was athletes, it was well-being, kind of using biometrics to optimize performance and diets, and we had a group of professional athletes and national federations, Olympic teams that we were constantly speaking with, kind of trying to dissect and foresee where we were making mistakes. And that never stopped throughout development. And we found ourselves making massive mistakes when we closed those channels because we were head down doing development. So that's something I think that you should constantly be keeping on. And as you progress, that could definitely change. Whereas yeah, initially you're solving, I guess, a super specific problem for a small fraction of the people. When you start looking at maybe growth or expanding the applications that your technology can have, you kind of widen that window, and that's when you have to prove a different type of market fit. The needs are slightly different. The pool of people has different criteria of adoption. So I think it's constantly refining that. But I will start with that initially, and then constantly refine it with time.
A lot of folks kind of feel like, oh, it's all in the idea. Like, I got to go protect this really essential idea. If I don't have that, if this idea is not protected, then I'm going to lose the competition. That's not the hard part of entrepreneurship. The hard part of entrepreneurship is execution. And most people that are good at execution would prefer to execute their own ideas than yours. So like, I tend to be not that scared of sharing my ideas early, because execution is a very scarce skill. Like, quality execution is a very scarce skill. And yes, the people that are good at execution already have too much stuff to do, right? They're like, well, I'm already running two of my own companies. I'm also doing this. Like, what am I supposed to do with your idea? No, sorry, I'm busy, right? So the people that could steal your idea are kind of too busy. The only folks to actually be scared of are the folks that literally work at your competitor of a big company. So they do know how to execute because they're in a big company that executes something that's competitive to yours. And they're actively looking for new directions to go. Like, yes, do not share your IP directly with a direct competitor that is literally producing the thing right now. But outside of that, your ideas can be widely shared. If you were to go tell your idea to 100 people, then what's going to happen with 100 people is 90 of your 100 are going to be like, cool, man, good for you. I'm glad you're working on some stuff. And they'll just be happy because you're passionate about working on something. But honestly, they will have no particular useful feedback for you just from the idea. Like, if you test a prototype, you'll get useful feedback from the usage of the prototype. If you're just sharing the idea, then 90% of people will give you no useful feedback. 5% of people will be total detractors and like just throw all sorts of stuff in your way. I don't care that you're passionate about this. I'm going to be a curmudgeon. I'll devil's advocate this thing to death, and just ignore them. It's useless. But then like, there's only going to be like 2 to 5 people out of the 100 that are as passionate as you when you share the idea. And those are the people that you should be working with. Those are the people you should be contracting, potentially hiring, having them become your advocates. And you're not going to find those people. You're not going to find those 2 people per 100 until you go share your idea 100 times.
Personally, I believe IP is important to show value, but I don't think that's the most pivotal thing people should be focusing on. A lot of people are obsessed with IP, and I think that that's where all the value really comes from. And we strongly don't believe that's the case, in the sense that nothing beats a product that works, and IP doesn't mean that works. And IP doesn't mean people are going to be using it, and IP doesn't mean that you're going to be a great success. And I think IP at a certain stage it becomes something serious that you have to work on, because one, it shows value. Two, long term, people will get your product in their hands, and especially a competitor, if they can disassemble it and build it exactly the same, that's a problem, of course. But I wouldn't say IP is, even in the space that we're in, which is an IP heavy industry, it's not the most important thing in our opinion. And I think one of the things probably, and Bill, and I think those are even some of the learnings that you probably taught was there's the risk is to put too much emphasis towards on how the tech work and why it's unique and why that's important, without testing why would people buy it and why would people use it. There is a balance there, but I personally wouldn't put IP as one of the most important things that a company should be focusing on, especially in the early stages. Think about it from the beginning, but be strategic about when you want to deploy the strategies to protect your IP. And this goes even with patents, right? The temptation is just file anything to show that you have something you can protect or something unique, right? And that's something that I think that's also something that we internally struggled with, because unless you have a patent, a lot of investors wouldn't show, hey, what's unique about what you're building, right? And the temptation is get a draft out there, get it filed, which is pretty easy. But in the end, is that strategically the right choice you should be making? A lot of the cases, that's not necessarily true. Earlier is not always better with IP.
I'm just going to give, there's like areas, because each company is different. So some companies file too broad, file too many in designations. Others far opposite way, far too narrow, far too few geographies. You have to make a decision around, do I have a line of sight to sales in that region? And if I do, then it's worth me protecting my IP. The sad thing about patents is if you do not, you'll have a deadline, and if you do not take that region at a certain deadline, you will not be able to apply for a patent in that region. So, you know, companies often make mistakes around that. You know, most companies get advised by patent lawyers. One of the disadvantages of that is a patent lawyer is incentivized, obviously, as most lawyers are, to take as much of their time as possible. I've seen patent costs go very high. I would definitely seek out startup-friendly lawyers that have flat fees. So we work with quite a few. You know, one that's been great for us is called Alpine Patents in San Francisco. So, you know, you know, Brian, his name is, it's like a solo outfit. But you know, he's great because he's got Stanford mechatronics and electrical engineering as his background. Then he did law, so he really understands the technology. Charges a flat fee to start up, so you know exactly what you're getting. And he's just incentivized to make it as efficient as possible.
That is actually your fitness function, right? Like in the absence of it, you have no way of telling what happened, right? So in a scientific study, there's typically a thing that you are measuring that is going to be your ground truth. And it might be like, oh, we heated up this metal and here's like its cooling curve. So like our ways of measuring temperature is the way that we're able to get to some truth around this. In every business, it is basically customer feedback is the instrument for ground truth. And imagine you were trying to do a scientific study and no way to measure results, it'd be chaos. Or imagine, you know, you're flying a plane, none of your instruments worked. It's like, it's dangerous. It's not impossible, but like it's highly not recommended. So same sort of thing. It's like, has there ever been a business where the people flew blind and just happened to land? Yeah, but it's real dangerous. So like you want to have your instruments that'll ground truth. You want to have the ability to get that feedback. And it's pretty easy to go find out if a business is starved for feedback, and that will absolutely kill the business. There's very few businesses that are over-indexed on customer feedback. So like you almost definitely have too little. It's just a question of whether you have like, you know, so much, like so little of it that you're deathly ill versus you have, you know, you're a little hungry from time to time. That's like the range that I've seen on startups.
So we've got a company called Wazer that have an exceptionally complicated technology. It's fantastic technology, but it's complex, i.e. lots of moving parts. It's mechanically complex. And so they need to have a really good cost of goods for their customers in the US. They also need to run this device. So it's a water jet cutter, desktop water jet cutter. It's kind of, think about it as a more versatile, sophisticated version of a laser jet. They get a large number of the custom parts made in China, and then sub-assemblies manufactured there and tested. But then they also have the larger metal parts, the cosmetic parts, and some more expensive parts sourced in the US. They then do all of the assembly and testing in the US, which enables them to do reverse logistics well. So they can, have, if there's any problem with any of the cutters, they can immediately get shipped back. They'll ship them a new one, and then they'll understand what's gone on with it and replace the part in it, and then be able to send that machine back out once it's been fully refurbished. Yeah, I think where I've seen people go wrong is trying to scale too quickly. There's an automatic kind of thought process a lot of people go through where they try and reduce cost very aggressively without thinking about the time implication of that cost. And if they'd actually just sat down and done very simple, back of an envelope calculation, they would have worked out it was better to do things in a less immediate cost-effective way, because overall it saves them time and money. Particularly when you're burning 150, 200K a month, saving 50K on a tool that takes you an extra 6 weeks really does not make any sense.
There's particular things that you can do in conversation, and there's particular things that you can do with, full production development. But, the pitfalls that people come into is they will try to go and make decisions by just getting stakeholders aligned. So basically try to do it through conversation. So let's say there's an important thing that we need to do in terms of making a decision about how we're going to go to market or how we're going to change some feature in our product. And the way that we do it, the methodology that we're using is, let's just sit around a table until all the stakeholders agree. Well, I'm just going to tell you, you don't have enough information in that system to make the decision well. So like, whenever smart people have enough information to make the decision well, they'll solve it quickly. So if I gave you the equation x plus 5 equals 10, you solve that pretty quickly. There's certainly enough information in the equation to go figure how to solve for x. But if I gave you the equation x plus 5 plus question mark plus y equals question mark divided by question mark times 2, solve for x, you'd be like, obviously can't be solved. There's not enough information right now to go do it. And most of the time when people are sitting around a room debating how they're going to solve a thing, they're working with an equation like that. And they'll look at the couple things that are visible, like the number 5 is in the equation. Let's really, obsess about that. And they'll forget that 3/4 of it is question marks right now. Now, how do you get rid of the question marks? Like, because clearly once you get rid of the question marks in that equation, this is very fast to solve, right? Like, well, the normal way that people would deal with the question marks is like, well, we need to get actual outcomes that we can look at. But if the cost of making actual outcomes is for you to go into a full production cycle, whether it's a software production cycle or hardware production cycle or a chemistry and materials production cycle, and it's going to take you 6 months to get rid of one of those question marks, then it's just going to take you a long time to go and solve that equation. So you're hamstrung in either situation. You either are going to use conversation, which is kind of faster, but it swirls around because people kind of intrinsically know there's question marks, and then you'll make the wrong decision on partial information. Or you go the slow route of like, okay, we'll clear out all these question marks, but each one of them are going to take us 6 months to build. Well, you add that up, like let's say you got 9 question marks, that's more time than a startup has to live. So like, that's why you're hamstrung on each of those situations. rapid prototyping is the thing that's in between that gets you the best of both, where you say, okay, we're not just going to debate about stuff to clear out these question marks. We're going to try to make stuff, but we're going to try to make stuff as inexpensively and as quickly as possible in order to get some sort of signal back. And look, sometimes people freak out where it's like, well, what if the experiment wasn't right? What if you don't get the best signal from it? Well, luckily, the experiment only took you 2 days. So the amount of time for you to like, well, let's tear that up, because typically if a thing methodology-wise is not getting you good data, you'll see why when you go and try it. And it's like, if that only took you 2 days, then you're like, cool, we could collect the data a little better if we were to tweak this, or go a little higher fidelity on this, or get in a better proxy of the user over here. And if you aim to go make your prototype in a day or two, then you will go track to something that is clearing out that question mark, within a week or two, as opposed to if you say, well, we can only solve this through full-on production, then yeah, buckle in for 6 months basically. But that also does solve the problem, but you need to have infinite time to go solve the problem like that. So the first one you kind of paraphrased real quick, but it's basically the goal of your organization should not be to debate things until you think that you're right. The goal of your organization should be to maximize the rate of learning in all the areas that you want to excel. And the way that you maximize the rate of learning is you minimize the time to try and see the results of new things. So then you kind of, then it leads to a thought process where you say, great, what does it take for us to try a new thing right now? And I will oftentimes sit with the team and we'll diagram it out. And it might look like, oh, we kind of sit around and we debate for 2 weeks what we're going to build. And sometimes that really is just a series of meetings. Sometimes it just happens, slowly through a daily stand-ups or whatever. But, I have them sit down and say, okay, the amount of time that we talk about a thing before we start doing anything is this much time. Then there's a certain amount of time it takes for us to actually make the thing. And then there's a certain amount of time for the thing that's made to get in front of customers so we can see any kind of result, or get in front of the folks that would be affected. Sometimes it's an external customer, sometimes it's an internal person, but whoever is whose life is supposed to be changed by this piece of work, there's some time it takes to get in front of them. And then there's some time where those results have been generated, but there's some time for those generated results to come in and affect future decision making. And we basically, size out the length of each one of those 4 in terms of actual, hours or calendar days. And then we ask ourselves the question, and I say, this entire thing, these 4 segments together, that's your learning cycle time. And now we're going to take whatever number this is, and we're going to try to bring that down by a factor of 5. So, and typically if you aim for a factor of 5 or 10, you'll easily achieve a factor of 2 or 3. And it's a very noticeable change to how they're working once they're learning 3 times faster. Actually it's useful to be very detailed, but like it's the order in which the detail is attended to. So if you attend to a bunch of details before you show it to any customers, then you're basically spinning on those question marks again. And you can try to get, and this is why I call about like obsessed, like people will get obsessed about the things that they can see, and they'll swirl around and not really resolve the question marks. But if you get real detail orientated after you've shown a thing, so let's say I made a prototype and took me a day, I put it in front of 4 customers, and then I got really, detail orientated about all the feedback that those customers gave me, then yes, that will tend to speed me up. If I try to obsess on those details before I show customers, I'm going to pick totally the wrong details to improve. Because people will be like, our logo's not really looking right yet. Like I want it to, can you put that on a transparent PNG and then shrink it down a little? And it's like, dude, trust me, this is not what the customers are going to be worried about. And I know you're generating the ticket and it's just all part of like how you work, but like you should just do a test right now. It's already fine. And then they'll go and do the test and they'll find it's like, our search algorithm sucks. Oh, we have the wrong inventory. Like stuff that's like real fundamental that they would not even think was going to be the problem is like, oh, that's the main problem, duh. And now you want to spend, the time that you need to change your search indexing, or the time you need to change the physical presentation and layout of what's on there. So, especially people that come from a scientific background, and some of them some of like the safety related engineering disciplines, right? Because like if you are in a civil engineering discipline, you don't want to make a mistake and have the bridge fall down, right? And if you're in a scientific discipline, there is a cost to being publicly wrong, right? If you publish a paper and your methodology is total crap, or your results interpretation is total crap, or you like end up with things that are completely refuted, you know, like because of true errors, then there's a real professional cost. But in the entrepreneurship world, it's really not like that at all. And it's, you know, it's way better to be out there earlier, making mistakes with customers earlier than it is to try to believe that you're resolving to the one fine thing. Because remember, there's going to be 20 or 50 design solutions that work. It's really just what's the amount of time before you resolve to any one of those. It's not that if I just took more time out, I would figure out the perfect 1 out of 20. There is no perfect 1 out of 20. That's not what the game is.
Be cautious about what people say they want. Listen intensely to anything they say that's wrong with your product. Don't be fooled by thinking that you can listen to your customer and they can give you the advice on what your next product should be. That's just not the case. Henry Ford told us that a long, long time ago, and anybody who thinks that is just it's just ridiculous. But when somebody's actually using your product, you have to remember that in general, the customer is completely stupid, right? Because they're never going to use this thing the way you'd envisage them using, because you're really smart and they're really stupid. And that's kind of the attitude. They're not, they're actually just people who happen to look at things in a slightly different way to which you might have looked at things. But you need to kind of assume that the customer is completely stupid, because only then will you really listen to every single problem they have and think about every single thing that could go wrong, because it's never going to occur to you. I mean, you never stop designing it.
Okay.
Yeah, and you need to build that into the to the development of the technology. It's never going to be ready, but that's okay. That's fine. Software is the best way to update things. So what you want to do is get the hardware as resolved as possible. And what we often tell companies is open soft tools, so cheaper tools which have a short lifespan, because it enables you to then change things for a later stage. Moving to a hard tool is it's going to save you an amount on your plastic, so polymer moldings, but not a significant amount, and it's much better just to make sure you've got the design fully optimized.